From playing ping pong with water droplets to lighting things on fire in microgravity to growing space salad, astronauts on the International Space Station get to experiment in one of the most unique laboratories known to man.
The water's all over my hands. In fact, it rings out of the cloth into my hands.
Around the moon, look at that.
Hovering 240 miles above us, the ISS hosts scientific investigations that not only benefit us here on Earth, but will hopefully bust us out of orbit one day. But how do these experiments get designed and prepped for microgravity? We're here at NASA's Kennedy Space Center to find out. CRS-15 is a joint SpaceX, NASA, and CASES cargo resupply mission, carrying over 5,900 pounds of gear and scientific research. Aboard this SpaceX Falcon 9 rocket will be 20 moustronauts, an artificial intelligence assist named Simon, and over 20 scientific payloads. At the Space Life Sciences Lab, researchers are busy prepping an experiment on space algae, a potential food source for deep space missions.
Algae are really versatile, so in an unstressed condition, they're very rich in protein and have a bit of starch and a fair amount of oil in them. It's very photosynthetically efficient, so you don't need a lot of light. You need much, much less light than you would for growing, say, even lettuce. The way that people that are producing algae for, say, biofuels and things like that, they grow them in liquid because you can get much higher yield, much faster growth. And so that was kind of the goal, is to figure out how can we grow algae in liquid in a microgravity environment? And so we're basically using gas-permeable bags to then be able to grow liquid cultures. Then we put a large amount of those cells into a starter culture. That culture sits in the dark for about a week before it then gets installed into the veggie unit for light.
Scientists like Dr. Settles work closely with CASES payload analysts to make sure their experiments are ready for launch.
Part of my job as a payload developer is to try and take the experiment that the researcher wants to do and make it as simple as possible for the crew. When the crew is up there working after a long day, you don't want very complicated procedures, you don't want complicated hardware, you want to make it clean and simple. We load that up and get it ready for flight. We package it in a flight-approved foam container, and then we'll take that over to Kennedy Space Center to hand it over to the NASA group.
NASA's Space Station Processing Facility is a 3-story, 457,000 square foot building where ISS modules and flight hardware are processed. It's also the next checkpoint for science experiments en route to the ISS. The space algae payload, which looks a bit like a pizza delivery, is handed off and vetted by NASA employees before being loaded onto the spacecraft, ready for liftoff the next morning.
Go for lunch.
3, 2, 1. Ignition, liftoff.
At about 9 minutes and 30 seconds after liftoff, the SpaceX Dragon spacecraft separated from the Falcon 9 rocket, making its way towards the ISS. Days later, the ISS's Canadarm2 played a careful game of robotic catch with Dragon.
Station capture complete. Looking forward to some really exciting weeks ahead as we unload the science and get started on some great experiments.
Our payload is scheduled to be installed in the hardware on Space Station within 24 hours of docking on ISS. The samples that we're working with are live organisms, so they can't stay in stowage for too long. Once our hardware is installed in veggie, our experiment will run for 1 month.
The hope with this investigation is to see how microgravity stimulates changes in different algae strains. By identifying genes associated with faster growth, Settles and his team can hopefully better engineer algae for space food and fuel.
So the nice thing about algae is that it grows relatively fast. In 3-6 days, you're already producing something as opposed to waiting 3 months if you're growing a large terrestrial plant. At the same time, it would help capture the carbon that the astronauts are breathing out and then turn it back into biomass.
Technologies used for this space algae experiment are already being used to help us grow crops more efficiently, like the LED lights, the watering system, and the small spaces. That's all thanks in part to experiments like this one, which is just one of over 250 active scientific investigations that can benefit us here on Earth. For more science documentaries, check out this one right here. Don't forget to subscribe and keep coming back to Seeker for more videos.